Neural networks power your photo unlock, your language translator, even fraud detection at your bank. In the next few minutes, let's speedrun the most important types with crisp, real-world examples. Think of a neural network as a layered calculator that learns its own rules. You feed it examples, inputs, and desired answers, labels, and it tweaks tiny knobs, weights, to make better predictions next time. Example: predict house price from size and location. At first it guesses poorly. With each example it adjusts its weights via gradient descent to reduce error, the loss, until its guesses get reliably close. Training: bound learning from data by minimizing loss. Inference: 1. Using the trained model to make fast predictions. Regularize: dropout, weight decay, early stopping, to avoid overfitting and keep the model general. Perceptron, logistic unit, foundational, is a single neuron that draws a line, or plane, to separate classes. Great for learning the idea of weights and activations. Limited on its own, but forms the building block of deeper nets. Example: spam versus not spam. Very simple features. Feed forward, multi-layer perceptron or dense nets. Feed forward, meaning one-way neural network. Stacked fully connected layers that learn complex patterns in tabular or compact feature data. Strong baselines for many business problems when data isn't image, on audio, text-heavy. Examples are credit risk scoring, churn prediction. Convolutional neural networks, CNNs, use learned filters that slide over images or signals to detect edges, textures, and shapes, building from simple to complex features. They're the go-to for vision tasks. Examples are face unlock, defect detection on assembly lines. Recurrent neural networks, RNNs. Designed for sequences, they read tokens step by step, passing a running memory forward. Classic choice for time series and earlier NLP before attention took over. Examples are forecasting sales, basic speech modeling, long short-term memory, or gated recurrent unit, gated RNNs. RNN upgrades with gates that decide what to remember or forget, solving long dependency issues. Still strong for time series and sensor streams when data is moderate. Example: predictive maintenance from equipment sensors. Transformers use self-attention to let each token look at every other token, capturing long-range relationships efficiently in parallel. They dominate modern NLP and are expanding into vision, audio, and multimodal AI. Examples: GPT-style chat, code assistance, translation. Autoencoders. Learn to compress data into a small bottleneck and reconstruct it, discovering essential features. Useful for dimensionality reduction, denoising, and anomaly detection. Example: flag unusual transactions without labels. Variational autoencoders, VAE. Like autoencoders but probabilistic, they learn a smooth latent space for generating and interpolating variations. Great for control generation and data exploration. Example: synthesizing realistic but diverse product images. Generative adversarial networks, GNNs. Two nets play a game. A generator creates fakes, a discriminator tries to spot them, both get better. Excellent for high-fidelity image synthesis and upscaling with care around ethics. Example: super resolution for old photos, mock-ups. Graph neural networks, GNNs. Operate on nodes and edges, passing messages along connections to learn from relationships. best where structure matters more than raw features. Example: fraud rings in payment networks, molecule property prediction. Siamese or metric learning networks are twin networks that learn an embedding space where similar items are close and different ones are far apart. Perfect for matching, verification, and few-shot tasks. Example: face verification, duplicate question detection, sequence to sequence, encoder to decoder. An encoder turns input sequences into a compact representation. A decoder generates the output sequence. Pre-transformer versions used attention. Today, transformers implement this pattern at scale. Example: machine translation, summarization, reinforcement learning plus deep nets, deep Q network or policy nets. A network learns to act by trial and reward, optimizing long-term returns. Shines where there's feedback from the environment, not labeled answers. Example: game-playing AIs, robotic control, ad bidding policies, capsule networks, CAPS-nets. Model part-whole relationships and pose more explicitly than typical CNNs, aiming for viewpoint-aware recognition. Niche in practice, but influential research idea. Example: recognizing objects even when rotated or overlapped. Spiking neural networks, SNNs. Event-driven neurons that fire spikes, closer to biological timing. Energy efficient on neuromorphic hardware. Emerging for ultra-low power, fast response applications. Example: edge devices with tight power budgets. Pick the model by data type. For images and video, start with CNNs. Graduate to vision transformers as scale grows. For text, code, or multimodal, use transformers. For tabular business data, try tree models first. Use multi-layer Perceptron, dense feed-forward, when features are many and non-linear. Match model to problem. For time series, start with LSTM, GRU. Use transformers when you need long context. Graph data, go with GNNs. For anomalies or compression, use autoencoders or VAEs. To generate new samples, try GANs or VAEs. And for decision-making, use reinforcement learning with policy and value networks. Tiny domain snapshots. Example of banking domain: CNNs for check image OCR, GNNs for ring fraud, AEs for anomaly detection, transformers for document understanding. Example of retail domain: transformers for product search, Siamese nets for visual similarity, MLPs for demand forecasting, GANs for synthetic catalog fills. Example of healthcare domain: CNNs, vision transformers for medical imaging, transformers for clinical notes, GNNs for patient graph risk models, always with human oversight and compliance. Data quality beats model complexity. Start simple, baseline, then scale. Monitor drift, retrain on fresh data, and mind ethics, privacy, bias, and security. Neural networks are just flexible function learners. Each type fits a pattern in the world. Like tools in a workshop, pick the one that matches your data and goal. If this clicked, hit subscribe and save this to your AI playlist.